This is John. We're going to do a video discussing the seal circuit. This is the box I'm going to use. Remember, like last time, I'm specifically using a different setup than you have in the lab because one of the skills necessary for a technician is to understand where the different inputs and outputs are coming from that he's using. And in your previous labs, you should already have a list of input and output addresses. I'm going to use the green button here and the orange light. I'm going to write a quick program similar to what we've written before. I'm going to add a rung. I'm going to use a simple push button and an output like we've done already. I happen to know already that the input that I want is bit 2. It's the first input card, and it's going to be bit 2. Now my default bit was 0 when I double click, so I'm just going to change that to 2 to get the button I want. I want to add a description. Without the description, you're going to be chasing numbers, and your instructor isn't going to chase numbers either. So take that second to put in a good description. My output, I happen to know that my orange light happens to be also bit 2 on the output card. I only have one output card available. Default bit is 0. I'll just change that to 2. I'll give my program a quick verify. I have no errors found. And I'll give it a quick download. The program is just matching some settings during download. Now it knows that my processor's in run. I have to change it to program to download a new program. It does take a second. Be patient. Fortunately, I can speed it up a little bit with editing, but you will. It does take a second to download. Asked me to go back to run. I said yes. It's asking me to go online. I want to watch my program. So now, when I press my push button, my orange light will come on. And while I'm monitoring my program, when I press the green button, it becomes green, which means it's true. And my output becomes true. And my orange light is lit. However, when I let go of my push button, my light goes out. And that's what the program is telling it to do. Button pressed in, the rung is true. Button let off, the rung is false, the output is false. So, we need to put in a seal bit. I'm going to go offline so I can modify my program. Once offline, I'll save it, and then I'll save it again with a new name. That's called empirical programming. So I'm going to hit save. And it's saving it on the PC. I'm going to go ahead and put it in my H drive. You'll have a student drive. And I'll just make a new folder quick here. It says ladder, and I'll know that that's ladder files. And I'll change it to light. If you just save it, it saves it as untitled, and it overwrites the old untitled, and it doesn't really help you much. So I'm going to say light and save it. Now, before I modify it, I'm going to save it with a new name. And you might think, why would I do that? Well, if I were to go in and start modifying this program and mess it all up, and if I were to go in and modify this program and I thought it was working correctly, so I saved it, and then it turned out that something was out to lunch and I just really didn't get something right, I'd have no way of backing up. So by starting anew, and you can call it anything, some people give it letters, I try and make the new name somewhat descriptive so I know which one to look for. But now I can mess with the program called Light New all I want, and I can always go back to the old one called Light and get back to my latest working version. So now I'm going to go ahead and I'm going to add a branch. And I'm going to branch around my push button, and I'm going to use an input. And then we just touched on this in the previous lab. We talked about it a little bit in our previous video. But I want to, even though this is an output, I'm not going to use the output as an input. That's what a lot of people think, and then they really don't understand. I'm only going to use this bit. I'm going to use this output instructions address. An address is an address is an address. These are the same bit in memory. It doesn't matter that the instructions are different. In output file 3, bit 2, this is the bit that I'm using in this program. So when I give this output instruction a name, it's going to follow my bit down here. Very important. I know it may seem very simple to you, but sometimes it's hard to wrap our head around it. We're using the output address. We can't put an output in the left side of a rung. It's not going to work. We don't ever want to do that, and it won't verify, and the PLC is just going to honk at us. It's not going to like it. But I can use the address. It's just a bit in memory as an input. So now I can verify. No errors found. I can download. And we'll speed this up a little for viewing purposes. Go back to run mode. Go online. So now I'm going to press and hold in my green button. Hold the green button in, but now when I let go of the button, the light will stay lit. In the logic, we can see that when I press and hold the green button down, the output becomes true and the output bit becomes true. Remember, these are the same bit in memory. So now I have two paths for continuity, and when I let go of my push button, this instruction goes false, but because this bit became true, there has been nothing to make this bit go false, and I now have a parallel path around my push button. I can push the button again. It won't do anything. It's already on, but my light will stay on. Now, one problem. I can't turn it off. So I have to lose continuity through this rung. So I'm going to just toggle this bit to turn it off. Wouldn't really have to, but I just wanted to make that bit low before I went offline. I'm going to save it again, and I'm going to save it with a new name also, because I know it works, so I can always back up to where I am now. So I'm going to call my next one that I'm going to start modifying, I'm going to call that stop, because I'm going to put a stop in it. I'm going to use this selector switch for my stop. I need a normally closed bit, and I know that when this switch is in the right position in auto, that it is bit 0. So I'm going to use an examine on instruction. I'm going to use an examine on instruction. Even though my switch is normally closed, we'll talk about that in later. We'll talk about that in some upcoming lessons as well. But I want an examine on instruction, and this is going to be my input bit, module 1 bit 0, that first available bit. I'll call this stop. I'm going to verify it and download it. So now you'll notice my stop instruction became true right away. That's because the switch is a normally closed switch. We'll talk a little bit more about push buttons, limit switches, and sensors in a future lesson. But we've already discussed briefly normally closed contacts and normally open contacts in a push button. If I were to use a normally open push button and examine on instruction like I am doing with my green push button, I would have to hold down the stop button in order for it to run. I need this stop instruction to be true almost all the time. The only time I want it to go false is when I stop my motor. With my selector switch in auto or the run position, I press my green button, my output light turns on, my seal bit becomes energized, so now when I let go of the green button, my output stays true. My light stays lit. I'll forego the pictures because I'm sure you believe me that the orange light is now glowing. And in order to make this output false, I need to make this input instruction false, and all I have to do is turn my selector switch off of auto back to the manual position. As soon as this instruction goes false, my output becomes false. At that point, immediately, my seal bit becomes false. So now, even if I get this, I just flipped my switch back to the run position. Even if I get that bit, my motor will not start because I'm not sealed. In order to start it again, I have to push my green button again and start the process over. So this is a start-stop circuit. It's also used as a memory bit because we can store whatever bit this is in memory. It doesn't have to be an output. As the textbook mentions, it could be a binary file. It could be a bit in an integer word, any number of things, and we can store a 1. Right now we have a 1 stored. And the only time this 1 will go to a 0 is if I lose that stop instruction. And even if I get it back, my bit stays a 0. So I can use this for a system run, system enable bit. That's what we'll be doing in the next lab. I'm going to go offline and save it again. The lab will have you add a couple of additional items. I'll leave those to you to find some inputs and outputs that you want to use. Remember, the lab will tell you that for the address of your stop instruction, you must use one of the white push buttons. That's because those will stay maintained. When we press it in, that contact will stay closed. So we need to use one of those for our stop button. If we use one of the first 4 colored buttons, they are momentary push buttons, which means as soon as we let off, the contacts will open up just like our green push button. So we'll need to use one of the white push buttons for the stop. When you begin the lab, you can start with a program that you used before. Because it has your I/O configuration, you can save it with a new name, delete the wrongs, and write new. You can start from scratch. Just remember that if you want to start a program from scratch, you will have to go into the I/O configuration and auto-configure your I/O. Otherwise, when you download and go online, your processor will be faulted. It won't understand what inputs and outputs you want to use. Thank you.